Tiger Sensei!
More 7 Caillou action. Let's go. This is called approaching enemies. And the idea is that we're going to complete this calculate time function that takes a couple points, represented here as array doubles meant to hold 2 values, an x value and a y value. And you are to determine sort of the speed the enemy is moving from the distance between these 2 points and the time that it took to get there. They told us that the time interval is 5 seconds. That's somewhere in the description. Here we go, every 5 seconds. And then the idea is that from that second point, you calculate how long it'll take to reach you or your base that would be situated at the origin. That's kind of clear in some of these test cases that they provide below. Again, I won't read to you. Feel free to pause the video and read through this. Otherwise, let's get into some solutions. Okay, so to start, like I said, we want to find the distance between the 2 points. And we can use that with the time interval to calculate a speed. And then we'll determine the distance between point 2 and the origin. Point 2 will always be the closer. Because the challenge stated that the enemy is always moving directly towards you. So we can take the difference between that point and the origin to determine the distance left to travel to reach us. We know the speed, and so we can figure out how long it'll take until the enemy reaches us, and we'll return that value as a double. So a way you could go about this, let's say double, I'm going to call it delta x. We're going to calculate the difference in the x values and the y values, right? And we're going to sort of make a right triangle, and then the hypotenuse would represent the distance between the 2 points, right? If it helps you to sketch out a little picture of that, feel free, plot 2 points, say 100, 100, and 90, 90, or if you want to scale those down, you could make it 10, 10, and 9, 9, same kind of difference. Anyway, the first value will be the x value, so I'll say P1 at position 0, index 0, minus P2 at position 0. And similarly, we need that delta y either. Delta is a term we use in science and engineering. It just means a change, like a difference in values. So I'll say P1 at index 1, the second value. Remember, we index arrays with 0-based numbering, so element 1 is the second item. So we got differences in our x values and our y values, okay? And so, like I said, we can imagine sketching a line between 9, 9 and 10, 10, and we know the difference. We know sort of the lengths of the legs of the triangle, right? But with this delta x and delta y. And so if you remember Pythagorean's theorem, a squared plus b squared equals c squared, where c is the hypotenuse, we can figure that out. So we can do something like this. The distance between the 2 points then, bear with me, I'm just going to make up a function, a helper function. I'll say calculate hypotenuse, and given 2 leg values, in this case delta x and delta y. And we'll implement this function, right? Do it as a helper here. I'm going to make it private because nobody else needs to use it. It's like I think of private items as kind of like your internal scratch pad where you do your calculations and whatnot. People outside of your class don't need to use that. So I'll say public static. Static because it has nothing to do with creating instances of objects. I'm just doing a math calculation. Public static double, we called it calc hypotenuse, and we'll say double leg 1 and double leg 2. Again, in mathematics, they often use that term leg to describe the sides of a right triangle that are not the hypotenuse. So then for that, remember it's a squared plus b squared equals c squared, right? And we want to know what c is. We're given a and b; those are the legs, but we want c to sort of solve that. For c, then we would have that c is equal to the square root of. I'm just writing this out this way because I'm not on paper. Otherwise, I'd draw the math symbols for you. We could say leg 1 squared plus leg 2 squared. Hopefully that is clear in my sort of write up here with the best symbols that I have on the keyboard. And to do that, then we can say return. The math class has a function called square root. You should look up the math class. It has lots of useful math functions for you. And then, so we're taking the square root of whatever's in between the parentheses. And again, we're going to use the math class mathPow, which just allows you to raise values to a power. You say the base amount that you want raised. So in this case, I'll say leg 1. And the second parameter is what value you want it to. If you wanted it cubed, you could say 3. If you wanted it to the 5th power, say 5. Since we're squaring, we're going to say 2. So we have leg 1 squared, and we're just going to repeat this for leg 2. And we're also squaring that one. And something like that. So hopefully you were able to follow along with the math there. Nothing too crazy, but it's just how I calculate the distance between 2 points on that Cartesian coordinate system, that 2D plane X and Y axes, right? Okay, so now I have a distance traveled. That's good. I know the 2 points represent a 5-second time interval from the rules of the challenge, so I can obtain a speed value from that, right? And the speed would be equal to the distance traveled divided by the time it took to do that, right? Think of how we talk about speed in miles per hour if you're in America like me, or maybe kilometers per hour if you're somewhere else in the world. And so I'm going to say that distance we calculated divided by our time, which I'm going to try to follow a best practice here. I'm going to say private static read only double, oops, spelling matters. I'll call it time interval. And that's, the fixed interval they gave us, which was 5 seconds. Oops, semicolon. We're not writing English here. If you haven't seen the F that's included with decimal values like this, it just says that it's a floating point value. You can also capitalize the F. It doesn't matter. Again, I made it static. It's just a single value. I don't want to create time interval doubles for every object that could be created by a radar class. I just need one value, so that's why I went static. Read only because I have no intention of changing it. It's supposed to be a constant, right? And then we do it like this. So if you reference time interval in multiple places in your code, you have one place where you can change the value and everything gets updated. That's sort of why we do this. So, and then now we can use this time interval to get our speed, right? The distance traveled over the time it took. Okay, good. We're most of the way there. So now we know how fast the enemy is moving between 2 points away from our base. And the idea is that their movement remains in the same direction, heading directly towards us at the same speed. That's obviously not real life, but this is 7 Caillou Challenge. That's what they're giving us. So we can basically do the same thing we did, right? But now instead of between point 1 and point 2, we're calculating between point 2 and the origin. So I'm going to calculate that distance that's left, and I'm going to divide that by the speed that we calculated to get the time, right? So like, think about it. If I told you I had to travel 120 miles at 60 miles an hour, right? You would tell me that it's going to take me 2 hours, right? You would take the 120 divided by 60, and that's what we're going to do here. I'll sort of combine this then. I will say, if it's easier to break it out into two separate steps, go ahead. I'm going to leverage that calculate hypotenuse method again. This time, like I said, we're going to go from P2's x value and P2's y value. And the reason why I don't have to do any delta here like I did originally is that we're going with respect to the origin now. So it would be, we could say P2 0 minus 0, right? And P2 1, the y value minus 0, because the origin is at 0, 0, right? But hopefully you see that subtracting 0 isn't going to change the value. So that's why I didn't have to do any kind of delta thing here. And then again, divided by the speed would give us the amount of time, right? If you have 120 mph, miles per hour, divided by 60, right? Or I'm sorry, 120 miles, I said in the example I gave you, divided by 60 mph, miles per hour, right? So dividing by 60 is the same as multiplying by the reciprocal, right? Times 1 over 60. And then you see the miles units would cancel out and leave you just with a time amount. So you get that two hours, right? That's sort of what we're going for here. We're trying to obtain a time, right? This is called calculate time. So I'll remove that. Just hoping this is clear for you at this point. I think we're good. Let's hit some testing, see if I did anything stupid, which definitely happens. Okay, we hit the basic tests. We'll hit the other ones before we go. And we could submit here. And if you want to, that's fine. You can be done. I'm going to do a little more realistic implementation of this. If you want to stay around for the extra credit, I highly encourage you to do that. One thing I really didn't like about this, and I see beginners do a lot, is they'll take arrays of whatever type if they're working with doubles, and they'll pack it with a bunch of values that represent something. And the whole idea of object-oriented programming is that we don't do that. We create classes and we give meaningful names to these data, and it makes it a lot easier to think about and work with. So I would never represent points as double arrays. You know, there's some obvious problems here too. What if the double array, you could legally pass in an array with one value in it, right? And that would break our program. We would crash here once we tried to access element 1, the second element. It wouldn't even be there. So in reality, in the real world, you'd be protecting against those kind of cases. You wouldn't want your code like this to be that vulnerable. You have the responsibility to sort of validate your input. So to that end, I'm going to create a point class. I've had to work with points before, and yeah, why not just make a point class for it, right? So we can say, don't be afraid to make classes. That's another beginner thing that people shy away from. Get comfortable with making classes. Normally these would be in separate files. Because of the environment here, I'm just going to make my class right here. I'm going to say public class point. But classes are your friend. Get comfortable making them. You want to make them a lot. You want to make them very small, focused, single responsibility. Do one thing simple and do it really well, right? And then you have lots of these classes and you sort of integrate them. You build them together like Legos. That's much better than having only a few classes that are complicated. It gives you a lot more flexibility too when requirements change. It's a lot easier to change a bunch of simple classes, meaning you don't have to change, you can change only the relevant ones. Anyway, I'm kind of getting off on a tangent there. I'll continue. So we have our class. Let's make our constructor, which is the public keyword followed by the class name. And it's going to take a double for an x value and a double for a y value. This is what a point is, right? We're going to have some body here. You can imagine we're going to want some fields that will hold the x and y value. I'm going to make them public properties because it's reasonable that a person working with a point would want to know the x and y value, right? And this could be a good introduction to properties in C# for you if you're not familiar with those yet. So let's say public double X. Typically we capitalize the name of public variables. And the syntax may look a little funny, but bear with me. This is how properties work. They look like fields, like members, but they have these getter and setter functions, okay? And you'll notice I put just get, but I put private with set, and that means that users of our class can't change the value of X. They can readily get it, but they can't change it. You don't have to make set private. You can actually include logic here that would validate your input, and that's a common practice. We don't need to do that here, so I won't speak any more about that. But same thing with Y, right? So now users can access the values, they just can't change them. That's great. We're in control of our data, right? We're responsible for our class. I like that. So good. We have those values. Now, hopefully you can see in the constructor what we'd want to do is something like setting the X value, semicolon, and setting the Y value. Good. We've created a point object. Now we want to do something with it, right? One thing before we go, this calculate hypotenuse, our sort of scratch pad, this is going to be, I'm just going to move this to our point class. Radar doesn't need to be bothered with that. That's kind of a lower level detail. So we'll put it right in here. Good. Yeah, that looks okay. I'll leave that there. And then finally, what I want to do as a helper, like our class, besides just creating a point and offering the XY value, I want to offer this nice feature. I'm going to say public double get distance to. And so this will be a method that takes another point. Sometimes when people do this, they'll call it point other, whatever you want to name your argument. That way, whatever instance, any point instance can calculate the distance to another point provided, right? And so we can just return our calculate hypotenuse, px. We're saying the point's x value minus this instance's x value, and the point y. Remember, it's our leg distances, right? Our leg sizes. So we're just calculating the difference between the x and y values of both points involved. Something like that, right? And so, right, this is a nice small class. It offers this helpful feature. We've sort of hidden calculate hypotenuse as a private thing, you know, within our point class. Radars shouldn't be, you know, worrying about low-level math like that. So then, now that we have this, we can make our implementation a little better. We can say, we could take a more expressive approach of this, right? Let's start by making a point for our origin, right? Or where our base is, if you want to name it something like that. This would be a new point with the values 0, 0, right? Now we're going to make points for each of the arguments that were passed in. I'll have point 1 equals new point, and that would be P1, 0, and P1, 1, right? The x and y values. We're going to do the same thing for y. Or I'm sorry, for point 2. Point 2 would be P2, 0, and P2, 1. Good. So now, when we want to get the distance like we did before, you could say double distance equals 0.1 get distance to 0.2, right? Isn't this a little more, when you look at this code, it's more clear what it's doing, right? It's more expressive, readable, maintainable. Then we can get our speed as the distance divided by time interval, nothing different there. And then finally, we can say return point 2, get distance 2, again with the origin, right? I think this is a lot more clear about what we're doing. If you come in and look at this code I just wrote, I think, it's more pleasant to look at. I know this is a simple example, so the difference may not seem as drastic, but it does matter as you work on larger and more complicated problems. So I like this better. Assuming this works, I'm going to keep this. Let's hit a test. Okay, I typed something wrong on line. Remember, they tell us the line number and the space number. So on line 29, what did I do? Calculate. Oh, sure, I see what I did. I used P as the argument name when we actually passed in PT. So let's fix that. Hit test. Okay. We got a bad calculation there, so let me figure out what I did for that. Oh, sure. My mistake. So we got the distance, but a distance isn't a time, right? So the time's calculated by the distance divided by the speed. Sorry about that. Just like we did in our example up top, we had to take the distance over the speed. My mistake. Let's try that again. Good. Green is golden. Let's hit the full suite of tests, and we're good to submit here. So I'm going to delete what I had here. And again, I know I could have solved this in less lines of code, but I'm trying to get you to think in more realistic terms here. So I'm going to leave my solution like this. I like that. They're going to make us run again because I changed code. Good. I'm going to go ahead and submit mine like this. You know what to do. Grab those kata points, review some examples, see if you can learn from other people too instead of just me. Otherwise, I appreciate you watching, all the likes and subs. Thank you very much. You keep me going, and I'll see you in another video. Thanks.